Hello everyone! Welcome ulit sa isang CS31 lecture video. Tapos na tayo sa accounting theory. So ngayon naman, sasabak tayo sa second part ng ating subject, which is yung graph theory. So ano yung dapat nating asahan? Since ito yung unang sabak natin, introduction, so marami ulit tayong mga kailangan makilala na terms. Para magkasundo tayo, meron tayong common language para sa mga terms na gagamitin sa module na to. Warning lang, hindi standardized ang terms sa graph theory. So, pwedeng yung terms na gagamitin natin sa module na ito, which is yung nakalagay sa Notion handout, iba sa terms na ginagamit sa ibang reference. So, kung halimbawa, manonood kayo ng ibang videos o kaya titingin kayo ng ibang books, kailangan nyo munang i-check din yung definitions nila to look for equivalent terms. Ang definitions na ginamit natin for this module, mostly galing sa reference book natin, which is yung Rosen book. What is a graph? The simplest description is that a graph is a set of dots and connections. So if we are um, to formalize a graph, we can think of a tuple composed of two sets, your set of dots and set of connections. The dots are also called vertices, and the singular form is called a vertex. The connections are also called edges. The singular form is an edge. So that's it. A graph is a set of vertices and a set of edges. But we have more terms coming up. So let's start with terms associated with an edge. So an edge is associated with the vertices it connects. And these vertices are called endpoints. So here we have an edge labeled E connecting vertex A and vertex B, and so we say that vertex A and vertex B are endpoints of edge E. Okay? How do we describe the relation between vertex A and vertex B? So we will say that vertex A and vertex B are adjacent. So pag sinabi nating adjacent, ang dalawang vertex, ibig sabihin may edge na nagko-connect sa kanilang dalawa. So sometimes maririnig natin yung term na a vertex A is adjacent to a vertex B. So ibig sabihin lang nun, may edge connecting A and B. Another way to say that, for example, A is an endpoint of edge E is to say that edge E is incident to vertex A. So, pag sinabi nating incident, that is describing the relation of an edge to a vertex. Okay? So, pag sinabi nating incident, endpoint ni edge E, si A. Okay? Usually, an edge is associated with two distinct vertices. Pero, pwede rin magkaroon ng case na an edge connects a vertex to itself. So, ang special na term for such an edge is a loop. So, going back to the terms introduced earlier, we see that vertex A is the endpoint of edge E. Vertex A is adjacent to itself. and edge E is incident to vertex A. So here we have a sample drawing and formalization of a graph. Ano ba nangyari dito? Well, nililista lang natin no, yung mga labels ng mga uh, vertices and edges dun sa tamang set. Now, kung mapapansin nyo, an edge can be mapped to the vertex or the vertices it connects. So, pwede tayong gumawa ng isang function describing such mapping. Ang tawag natin sa function na yun ay edge endpoint function. So, ano yung domain? That's just your set of edges. Tapos, ano naman yung codomain? So, diba, this will describe yung mga kinoconnect na vertex ng isang edge. So, this, your codomain will be your set of subsets of V having size equal to 1 or equal to 2. Okay? So, note na kapag na-connect natin ang isang edge sa isang subset of length 1, di ibig sabihin, meron tayong loop. Right? So, ano pa yung mapapansin natin dito sa edge endpoint function? So, mapapansin natin, hindi siya one-to-one, right? Bakit hindi siya one-to-one? Dahil kay edge E2 tsaka E3. They both connect the same endpoints. Ito. So, meron din tayong term na ginagamit to refer to edges connecting the same endpoints. So, ang tawag natin para sa mga ganitong klaseng edge ay parallel edges. Okay. So, more terms. The number of vertices and the number of edges in a graph actually gives an indicator of how big and how complex is a graph, right? So we usually take note of the number of vertices and the number of edges. At meron na naman tayong term na ginagamit to denote the number of vertices and the number of edges. At yan nga ay order and size. So when we say order of a graph, we are referring to the number of vertices. And when we say size of a graph, we are talking about the number of edges. Size is to edge, order is to vertex. Okay? So, ano yung order at ano yung size ng example graph natin? So, order is 4 kasi meron tayong 4 na vertices and size is 5 dahil meron tayong 5 edges. Okay, ano namang sinasabi nito? There can be many possible drawings that refer to the same graph. What is important is the connections made by the edges. So, totoo naman to, no? Para ipakita natin kung anong sinasabi niyan, yan. Meron tayong isa pang drawing nitong graph described here. So, mukhang magkaibang drawing, pero looking at the labels of the vertices and the edges, pareho lang naman yung dinidescribe nila na graph. some cases, it may be important to assign a direction to an edge. So, ano ba mga example nitong cases na kailangan mong lagyan ng direction ng isang edge? We usually use this to represent computer networks. No? Yung case, for example, na meron ka lang one-way communication. For example, pwede kang magpadala pero hindi ka pwedeng makareceive, or baliktad. Pwede kang mag-receive pero hindi ka pwedeng magpadala. Ano pa? Pwede rin gagamit ka ng directed edge. So, an edge with a direction to represent relations na hindi two-way. Ano ba? Ano ba yung mga relations na hindi two-way? Gusto mo, pero hindi ka gusto. Ayan. So, one way lang yun, no? Pwede mo yung i-represent via a directed edge. So here we have an example of a graph with the edges having direction. So, imbis na line lang yung edge, yung representation ng edge, magiging na siyang arrow. No? Mayroong tail at mayroong head. So, ang tawag sa graph na may directed edges, with direction, is a directed graph. Okay? So, meron lang tayong mga karagdagan na terms para sa directed graphs, specifically for a directed edge. Kasi kapag directed edge, kailangan na nating ma-distinguish yung dalawang endpoints. No? Kasi meron siyang pinagmulan at pupuntahan. Okay? So, here, yung source nung arrow, yung pinagmulan, tatawagin natin siyang initial vertex. Tapos, yung pupuntahan ay tatawagin nating terminal vertex. Yan. So, here we have an example drawing and formalization of a directed graph. So, ano lang ba ang gusto kong ipapansin sa inyo rito? Ito lang, yung itsura ng edge endpoint function kapag directed graph. Note na sa directed graph, we distinguish the endpoints. No? Nagmamatter yung order. And so, instead of a set to represent elements of the codomain, we are going to use tuple. So, ano na siya? Instead na yung curly brace, naging parenthesis na siya. Yung first of the pair will be the initial vertex, and yung second of the pair will be yung terminal vertex. So, question, what if we have a loop in the directed graph? Paano natin siya i-represent? Ano yung dapat na nakalagay dito sa codomain? So, for example, halimbawa meron akong loop dito kay V3. So, anong ilalagay ko dun sa codomain? Ano ba? Ganyan ba? Or ganyan. Ito o ito? So, ang sagot ay ito. Yung second choice. So, ibig sabihin, dito, we are saying na yung initial vertex ay si V3, tapos yung terminal vertex ay si V3 din. And that indicates a loop in the directed graph. Dito muna tayo magtatapos. In the next video, we will be talking about different terms involving neighborhood in graphs.